So now we need to talk about finding the derivatives of logarithms. And just like we started with e to the x as the basis for all of our other exponentials, natural log of x is going to be the basis for all of our logarithms. And this I did want to show you where the derivative comes from. It's very quick. I'm going to take e to the x, or y equals natural log of x, and rewrite it. Well, natural log, that's base e, y would be the exponent, and that would have to equal x. This is the exact equivalent of y equals natural log of x. And we can use implicit differentiation here to do our derivative. So derivative of the left side here, because it's an exponential, would be the exponential times the derivative of the exponent. And on the left side, or on the right side here, derivative of x is 1. So then dy dx, as we isolate it, would equal 1 over e to the y. But as we said right up here, e to the y is equal to x. So dy dx is equal to 1 over x. And this is our derivative for natural log. Some quick examples here. If I have my f of x is natural log of 3x squared, well, the derivative is going to be 1 over, my derivative is going to be 1 over what I'm taking the natural log of, and then the chain rule times the derivative of what's inside. And I can do simplifying there, but I'm not going to take the time on it right now. Again, if I have natural log of tangent x, the derivative is going to be 1 over what I'm finding the natural log of times the derivative of what's inside. Talk about is what if we don't have a natural logarithm? What if it's a logarithm of a different base? What we use here is we do a change of base. We change that logarithm into a natural log. So remember, the change of base is if I have a log base a and I want to change to natural log, I do the natural log of what's inside over the natural log of the base. And this is now all in base e, or natural logarithms. Well, the 1 over natural log of a I can separate out because that is a constant. So now when I do the derivative, it's the constant multiple rule, so the 1 over natural log of a times the derivative of natural log, which is 1 over x. Some people choose to memorize this. I will say I, for whatever reason, have trouble remembering it. I always just change my logarithms of other bases like this and then do the derivative. If I have the log base 2 of 3x plus 1, the first thing I do is change it to be 1 over the natural log of 2 times the natural log of 3x plus 1. And then doing this derivative, well, 1 over natural log of 2 is constant, so it just stays there, times the derivative of natural log of 3x plus 1, which would be 1 over the 3x plus 1, times the derivative of what's inside. Other examples here, we can use this in combination with other rules. So here I have the natural log of 2x plus 5 divided by 6x. I know a lot of you prefer the quotient rule, so I will go ahead and do the quotient rule on this, which would be the bottom times the derivative of the top, and that's the derivative of the natural log part, times the derivative of what's inside the natural log, then minus the top, natural log of 2x plus 5, times derivative of the bottom, which is 6, all over, oops, this is all over our bottom squared. Or in the second example here, g of x, which is going to involve the product rule, g prime of x would be first, whoops, before I do that, sorry about that, I just noticed I'm not dealing with a natural log, so I am going to change it into a natural log. So that's going to be, that's base 10, so 1 over natural log of 10 times x times the natural log of x squared. So now when I'm doing the product rule, I've got first times the derivative of the second, and then because of chain rule, times the derivative of what's inside, plus second times the derivative of the first, which will be 1 over natural log of 10. And my last example here, log base 3 of x squared plus x, that entire logarithm times x squared plus x. And again, I'm going to change this to be in natural logarithms. And this is going to require that I use the product rule. So h prime of x is going to be first times the derivative of the second plus second times the derivative of the first, which will be, there's my constant, 1 over what I'm taking the natural log of, times the derivative of the inside.